US Physics Olympiad, year 2020, F equal MA. First round, exam B. As usual, it was given 75 minutes for 25 problems. Problem number 1. A ball is bouncing vertically between the floor and the ceiling, which are both horizontal and separated by 4 meters. All collisions are perfectly elastic, and when the ball hits the floor, it has a speed of 12 meters per second. How long does a complete up-down cycle take? Problem number 2. A uniform rod of mass m and length L has moment of inertia mL square over 12 about an axis that is perpendicular to the rod and passes through its center. What is the moment of inertia of a uniform square plate with mass m and the side length L about the axis along its diagonal? Problem number 3. A conical pendulum of length d swings in a horizontal circle of radius small r as shown. If omega is the angular frequency of this motion, what is omega square? Problem number 4. In 0G airplane rides, passengers can float around the cabin as if they were weightless. A flight trajectory for such a ride is shown below, with a few points during the journey labeled. Which of the following statements is correct? Take A to be the acceleration of the plane during the 0G part of the flight. Problem number 5. A mote of dust is initially located at distance r from the Sun, which has mass big M. At this point, the mote has a small tangential velocity v. Which of the following is a good approximation for the distance of closest subsequent approach between the mote and the Sun? Problem number 6. A three-legged table is shaped like a uniform equilateral triangle and has identical legs at each corner. When the mass of an object placed on the center of the table exceeds m maximum, the table's legs will all simultaneously break. Which of the following shaded regions shows the area within which an object of 2m max over 3 can be placed without breaking any legs of the table? Problem number 7. Two satellites are initially in identical circular orbits around the Sun, with orbital speed v equal 10⁴ meters per second. The first satellite fires its thrusters toward the Sun and quickly obtain a radial velocity delta Vr equal 1 meter per second. The second satellite instead fires its thruster behind it and quickly increases its tangential velocity by delta Vt. If the two satellites subsequently perform orbits with the same period, approximately what was delta Vt? Problem number 8. A conveyor belt is moving with the velocity v to the east. A block with velocity v to the south slides from the ground onto the conveyor belt. The coefficient of friction between the block and the belt is μ. The block stops slipping after a time. Next one. Problem number 9. Two equal masses m are connected by an elastic string that acts like an ideal spring with the spring constant k and the unstretched length L. The two masses are hung over a frictionless pulley. What is the total length of the string at equilibrium? Diagram not necessarily to scale. Problem number 10. The two masses are both displaced downward by a small vertical distance x and simultaneously released from rest. What is the period of oscillations? Problem number 11. An escalator can carry passengers up a vertical distance of 10 meters in 30 seconds. A mischievous person of mass 50 kg walks down the up escalator so that they stay in place with respect to the building. If the child does this for 30 seconds, the total work the child performs on the escalator in the frame of the building is next one. Задача номер 12. A platform just out horizontally from the edge of the building. If the platform is modeled as a uniform metal rod, which one of the following statements about the tensile and the compressive stress is correct? Problem number 13. A uniform disk of mass m and radius r is attached at its edge to a flexible pivot on the ceiling. It is given a small displacement perpendicular to the plane of the disk, so that it begins to oscillate perpendicular to the plane of the disk. What is the period of oscillation? The moment of inertia of a disk about the axis going through its center and perpendicular to the plane is I disk equal 1/2 m r square. Problem number 14. A large block of mass 5 kg is moving to the right at a velocity of 10 meters per second. Spaced out every meter are smaller, initially stationary block of mass 1 kg. All collisions are perfectly inelastic. Neglecting friction, how far will the large block travel before its velocity has decreased to below 3 meters per second? Problem number 15. In the device shown, blocks of various masses are placed on a distance so that the device is in equilibrium. The fluid in the drawing is to scale. There are valves that are both initially open at locations A and B. One of valves is closed and the system is allowed to come to equilibrium. How will this affect the height of the mass M2? Problems number 16 and 17. The following information is relevant to problems 16 and 17. A mass big M sits on top of a vertical spring of a spring constant K in equilibrium. A mass small m is held height h above it. The mass big M is then pushed downward by distance dx, and both masses are released from rest simultaneously. For what value of h will the two masses first collide when big M first return to its equilibrium position? Problem number 17. Assume that h takes the value found in the previous question and that the collision between the two masses is perfectly elastic. For what value of dx will m small rebound to a maximum height that is exactly equal to its original height? Problem number 18. An extendable arm is made from rigid beams free to pivot around the dots shown. Spring 1 with the equilibrium length L1 is attached between points A and C. while spring 2 with the equilibrium length L2 is attached between B and D. The system is allowed to come to equilibrium. In equilibrium, what is the ratio of the tension in spring 1 to the tension in spring 2? Problem number 19. Consider an axially symmetric object that experiences no external forces and initially rotates about its symmetry axis. The object then changes its shape while remaining axially symmetric. Afterward, it is found that its moment of inertia about the symmetry axis has increased. How have its kinetic energy T and the angular velocity omega changed? Problem number 20. A well-calibrated scale reads 0 when nothing is placed on it. When a deflated balloon is placed on the scale, it reads m small g. When a non-airtight box is placed on the scale, it reads big mg, where big M greater than small m. The balloon is inflated with helium so that it floats upward in air. The balloon is placed in the box and the box is placed on the scale. If the scale reads W, which of the following is true? Problem number 21. A person stands on the seat of a swing and squats down, so that the distance between their center of mass, cm, and the swing's pivot is L. As the swing gets to the lowest point, the speed of their center of mass is v. At this moment they quickly stand up and thus decrease the distance from the center of mass to the swing's pivot to L prime. Immediately after they finish standing up, their center of mass speed is v prime. Which of the following statements is correct? You may neglect friction, the change in the moment of inertia of the person about their center of mass, and the time take to stand up. Problem number 22. A point mass m sits on a long block, also of mass m, which rests on the floor. The coefficient of static and kinetic friction between the mass and the block is mu, and the coefficient of static and kinetic friction between the block and the floor is mu over 3. An impulse given a horizontal momentum p to the point mass. After a long time, how far has the point mass moved relative to the block? Assume the mass does not fall off the block. Problem number 23. Assume that the drag force for a fish in water depends only on the typical length scale of the fish r, its velocity v, and the density of water ρ. A puffer fish is about 10 centimeters in length and swims at about 5 meters per second. How fast does a clownfish about 1 centimeter in length need to swim such that it experiences the same drag force as the puffer fish? Problem number 24. 3 boxes A, B, and C lie along a straight line on a horizontal frictionless surface, as shown. Box A is initially moving to the right with a speed v, while the other 2 boxes are initially at rest. If all collisions are elastic and the masses of the boxes can be chosen freely, which of the following is closest to the maximum possible final speed of box C? Problem number 25. If a certain radioactive decay process happens n times per hour on average, then in any given hour one expects to observe n decays with an uncertainty of square root from n. Each hour can be assumed independent of the previous one, and n can be assumed constant over time. How many hours do you need to conduct the observation so that you can determine n within an uncertainty of 1%?